Okay, so in mass analysis, we found mass current by using Cramer's rule, okay, by finding determinants. So I'm giving one example. So just solve it and tell me the mass currents given in the network. So you already know the method. And after that, we will verify our answer. Okay. If you do practice for this example, then and then you will get correct answer. And please make a book, a fair book for the subject. So by solving these examples or writing theories, you will understand easily, and that will be helpful. Okay, by reading and by seeing, that will not help you for understanding, and forget and you will not get good marks in examination by only reading and just by observing. Okay, you have to try for it. Okay, along with me, you can also just make it this diagram. Okay, this is 8 ohm. This is 30 volt. 30. Okay, now find out mass current I1, mass current I2. This resistance is 4 ohm, and mass current I3. Okay, so all values are given for the voltage source and resistance. You need to find mass current I1, I2, and I3. Just get the three equations by mass analysis, and by separating the terms for unknowns I1, I2, and I3, just make the matrix. Then find out delta R, delta R1, delta R2, delta R3. So I1 equal to delta R1 by delta R, I2 equal to delta R2 by delta R, and I3 equal to delta R3 by delta R. So just tell me the answer by getting this. So in yesterday we already did this. Okay, so tell me the delta R, what you are getting.
Sir, last one is 30 volt or 3 volt?
30, 30, 30.
Okay.
Okay. Okay, I am not used to of this board, that's why just I am not getting proper writing. But yes, after sometimes I will become used to of this whiteboard. So tell me delta R, delta R1, delta R2, delta R3. Your I1 is equal to delta R1 by delta R. I2 is equal to delta R2 by delta R, and I3 is equal to delta R3 by delta R. Okay, I am giving 5 minutes for this. So just solve it and tell me the answer. Make 3 equations, just rearrange the equations in the form of this coefficient of currents. This I1, I2, I3 are unknowns, and you will get on RHS side this voltage value. Okay, so you will have one matrix for resistance, second matrix for current, and third matrix for this voltage, or you can say constant. Okay. So first find out this overall determinant for resistance. Then for delta R1, to find I1, just replace the coefficient of I1 by this voltage or constant. For delta R2, change the coefficient of I2 by this voltage source or this constant, and for delta I3, just change the coefficient of I3. So you get delta R1, delta R2, delta R3. And
Sir,
according,
is delta R 598?
okay, first answer just I am writing 590.
Sir, delta
598.
R is 290.
Delta R equal to 598.
8.
Okay.
Sir, 290.
290. Okay, second answer is 290.
Sir, 472.
472. Anyone getting other answer?
598.
5. Okay.
598.
Yes, 598.
598.
598. Okay, majority is 598. Majority is calling 598.
Yes, sir, it's 598.
Okay, it's 598. Are all okay? All of you getting
598.
Just those who got this answer 472 to 90, please check the equations and find out correctly this determinant for this resistance value. Okay, so majority is 598. Now we will check at, okay, getting the correct answer or not. Tell me delta R1.
1200.
1530.
1 1.30
53.
1530 ohm. Okay, are you getting this, everyone? Other ones? You have enough
Sir,
time
it's
to.
sir,
Yes.
it's 135. Delta
One,
R1 is equal to
13
50.
1350. Okay, anyone getting this? Either 1530 or 1350. Okay, remaining other ones, what you are getting for delta R1?
Sir, 1530.
Okay, 1530. Please check for this answer. Those who replied this, please check. Are you getting 15 or 1350? Okay, remaining ones, are you getting this answer? This one is correct.
1348.
Yes, sir.
Okay, tell me delta R2.
1090.
Delta R2.
1090.
1090 ohm. Are you getting this? Other ones? 1090 is correct or
Yes,
not?
sir. 1090.
Okay,
Yes, sir.
good,
1090.
good.
1090.
Delta R3
1090.
Sir, minus 1965.
minus 1965. Delta R3.
Yes, sir.
Sir, delta R is 1380.
Delta R3
R1 1380.
1380.
Yes.
Yes, sir. 1380.
380. This delta R2 is correct. 1090.
Yes, sir.
And delta R3 are you getting minus? Just check. This answer is correct. Minus 1965. Okay, I am just checking the answer. Your delta that is equal to 598. Are you getting 598 delta?
Yes, sir.
Yes, sir.
Your
Yes,
delta
sir.
your delta R1 that is 1530. Correct answer. 1530. Delta R2 1090. Are you getting 1090 for delta? The correct answer for this, just I am writing, I am erasing this answer. I am writing the correct answer. Okay, the correct answer is,
I1, sir, 2.55.
wait, this is 598. Okay, this 598 is correct answer. Okay, 598. This is correct answer. Delta R1 1530. Correct answer. Delta R2 1090. Correct answer. And delta R3 minus 1875.
1875.
Yes, minus 1875 ohm for delta R3. So this is the correct answer. Delta R 598, delta R1 1530, delta R2 1090, and delta R3 minus 1875 ohm. Now, by getting this determinant for resistance, you will get correct answer. If you are getting this wrong answer for determinant of resistance, then you will get this wrong answer for current. Okay. So you have to get this correct answer. Then you will get this correct answer for mesh currents. So I1 equal to what?
2.55.
2.55.
56.
Okay, 2.55 or 2.56 ampere. I2
1.88.
1.82.
1.88.
82.
1.82 ampere. I3
Minus
Minus
3.13.
313.
minus
3.135.
135.
135.
3.135 ampere. So this is the answer. This is a mass current answer by using this. Okay. So still anyone having difficulty for solving this mass analysis?
No, sir.
For getting
No, sir.
equations, just
No.
first you have to get the correct equations. if your equation is wrong initially, then you will get whole thing wrong. So first step, you have to get correct equations. Just rearrange the equations correctly, convert into matrix form, find out the determinants, and then by using Cramer's rule, go for these mass currents. Okay. Now
Yes, sir.
we will move to the nodal analysis. Okay, just I am erasing this. So in nodal analysis, we will find node voltage. So in that we will apply KCL applications. So according to the Ohm's law, I equal to V by R nodes, and we'll get the equations, and after that equations we will convert into matrix forms, and same we will apply Cramer's rule. Okay, so here in the matrix form you will be having conductance, then second matrix is voltage, and on RHS side you will have matrix of current. Okay, that is your constant. So you know the reciprocal of resistance, that is called conductance. So here that is replaced by the resistance replaced by conductance in nodal analysis. So in nodal analysis, you have to find out the nodes available. You have to take one reference node. Initially, you have to assume the current directions, and after that, you will know you have taken the direction of current is right or wrong according to knowing of potential. As we know, current always flows from higher potential to lower potential. Okay, so initially we are assuming, but after knowing the voltages, we can say this the current direction should be like this. Okay. And I will give, okay, node and nodal analysis. So in nodal analysis, first what you have to do, identify available nodes in the circuit. Second, identify reference node. Okay, reference node, assume current direction, okay, generally just consider away from the node, away from node. So if we are considering away from node, so your node voltage should be higher potential. Are you getting me? If we are considering the current direction away from the node, so we know current always flows from higher to lower potential. So initially we are considering our node voltage is higher value, but after that, after getting the current, we will know our node voltage is higher value, or supply voltage is higher value. Okay. So initially we are assuming current direction that is away from the node. First, here we apply KCL application in nodal analysis. KCL application. Your reference node should be at ground potential. Should be at ground potential. node we know where two or more elements are connected together, so that is called the nodes. And for the reference node, we can say uh, where three or more elements are connected together, so that is your reference node. Three or more elements for reference node. And this nodes we will consider two or more. Or we can say the negative terminal of, or we can say the negative terminal of active element, or passive element, that is called your reference node. Okay, so this you have to keep remember while applying this nodal analysis and to get the node voltage. Okay, anyone having doubt in this rules?
Sir, can you
No,
repeat
sir.
once again the whole thing?
Yes, in nodal analysis, you have to use KCL application. In second, if you have network, then in network identify the nodes, how many nodes are available, because we have to find the node voltage. So identify the number of nodes are available. 3 nodes are available, so we have to find VA, VB, VC, 3 node voltage. If 2 nodes are available, then you have to find VA and VB only. Okay. So along with these nodes, you have to assume one reference node which is connected at ground potential. So that is your reference node. So reference node generally the negative terminal of active element, that is called your reference node, which is at ground potential. Okay. So with respect to reference node, you can apply this KCL applications. Initially, to find this node voltage, so take the current direction away from the node. So suppose we are considering away from the node, we are considering our node voltage higher value comparatively. Okay, so we are considering this positive node voltage initially or higher value of node voltage initially. Okay, as we know, current always flows from higher to lower potential. So just we have here one node is available. Suppose this node is available. So initially we are assuming away from the node. Okay, but later on we will know, suppose here we have one voltage source is connected, then suppose we are considering this direction, but later on suppose this one is initially is given 20 volt. We do not know this VA node voltage. Okay, but initially we assume away from this node, but later on we are getting this is 50 volt. So you'll get we have assumed this wrong direction, or you will get accordingly the current negative. Okay, if you are assuming this direction, then you will get the negative current answer. If you assume, so we have to take this, so our current will be positive. Are you getting me?
Yes,
Yes,
sir.
sir.
Yes.
Okay, so initially we are just assuming away from the node. If you are considering wrong direction, then you will get the negative answer. If you assume we correctly, then you will get the positive answer. Okay, so negative, positive doesn't matter. You will get the same magnitude, but sign you will get change by assuming this current direction.
Sir, our reference node is at ground potential. Then how current will move away from it?
That I will show you in network. Okay, that I will show you. You should consider reference node. So then and then, so I'm showing you network. So this is your nodal analysis. Now this is the network is given. How many nodes are given?
4.
4.
4.
Oh, which one? Which one?
2 nodes with
The
2 ohm resistors and
left to
2
right
nodes with 1 ohm resistor.
I am considering this one is our node A. This
yes,
is our node B. Then
below to the A, below to the B.
and we know three or more elements are connected. So 1, 2, 3, 4, or you can say negative terminal of active element. This is your ground. So we have only two nodes, and this is your reference. Are you getting me?
Yes, sir.
This is
Yes, sir.
Yes.
your VA, VB, and I am considering this is your V0 at zero potential. Okay, so we have two nodes only, V and VB, and this is your reference node V0. Okay, now you have to find only two voltages, VA and VB only. Okay, so by nodal analysis, by applying KVL application, just you have to get only two voltages, V and VB, and this V0 is your reference node, V0. So you can see here in the nodes, you have only two nodes, A and B nodes. This C is your at ground potential. Okay. Now here, as I told you, just consider the direction of current away from the nodes. Then here you can see this already current source is given in the circuit, 3.1 ampere. This 3.1 ampere, this is your current source, DC current, and this minus 1.5, 1.4, this is also your current values given, current source is given in the circuit, and the direction is already given. This is upward and this is downward. So initially I told you you have to consider away from the nodes, but here already direction is given. So this is I am taking inwards, and this I am taking onward, outwards. Okay, for this node A. You can also consider this away from, accordingly you have to consider this current value. Then node B, I am considering this one is inward, or you can also consider outward. Okay, and this both are away from the node. Okay, this also you can consider away from the node. Okay, so the current direction is already given here. You can see, okay, these both are away from the nodes. This is inward to the node. Then these both are away from the node, and this one is also we have taken inward to the node. Okay, according to these current source value. Now we have to apply this KCL at node A and node B. So you have to consider at this node A where it is connected. So node A is connected to this, and this. So you have to apply KCL. So according to KCL, suppose this node is connected first to this branch, then what is the equation? According to V by R. So VA by V by R. So VA by 2. Are you getting me?
Yes.
Then
Yes.
A is connected to this also. So you have A potential here and this is B potential, but we consider this direction from A to B. So you can write plus VA minus VB by 5. And this 3 ampere, you can see here minus 3, 1.1, or you can directly write here 3.1. Okay, you can write minus 3.1 ampere or equal to 0. So this is your first equation. VA by 2 plus VA minus VB by 5 is equal to 3.1 ampere. Okay. Then for B node, what is your equation?
VB by 1
VB by 1
plus VB minus VA by 5.
VB by 1 plus VB minus VA, because we assume the direction from outward. VB minus VA by 5 equal to
Minus 1.
Minus 1.4.
minus 1.4 or plus
Plus.
plus 1.4, because you can see the direction is downward, and if you are writing minus 1.4 here, that becomes plus. Okay, here you can see the direction current is like this. If your current direction is like this, then you will get this minus 1.4. Okay, but already it is taken outward, so that's why we can write this 1.4. So the equations will be Okay, assume potential at node A VA, potential at node VB at B. So 3.1 equal to VA by 2 plus VA minus VB by 5. So you will get 0.7 VA minus 0.2 VB equal to 3.1 ampere. So this is your equation 1. Applying KCL at node B, VB by 1 plus VB minus VA by 5 equal to 1.4. So we'll get the equation minus 0.2 VA plus VB, 1.2 VB equal to 1.4. Now make the matrix form. So this is the coefficient of VA and VB. VB are unknown. Okay. So just make the matrix of coefficient of this voltage 0.7 minus 0.2 minus 0.2 and 1.2. Other matrix is V and VB equal to this matrix of current. So you'll get this matrix. So this is your conductance, this is your unknown voltage, and this is your current. Now find out here delta G. Find out delta G, determinant, overall determinant, delta G. Tell me the answer for delta G.
5.
0.8.
Okay, if someone getting 5, then 0.8. Which one is correct?
0.8.
0.8.
0.8. So
0.8.
0.8.
yes, according to majority, it is 0.8. Okay, delta G1, just replace first column by this current value
4.
for delta G1.
4.
Answer is 4. For delta G2, find second column by this current value.
1.6.
Answer is 1.6. So just other remaining ones, just get this answer. .8, 4 and 1.6. So according to the Cramer's rule, V1 equal to what we can write?
Delta G1 upon
Yes, delta
G1 upon delta G.
V1 equal to delta G1
G1.
by delta G. Okay, and V2 equal to delta G2 by G. So this is your V1 and V2. So just get this node voltage. So VA or V1 equal to 5 volt. Are you getting 5?
Yes.
Yes.
And VB?
2.
2.
So
VB is equal to 2. So this is your nodal analysis. That just you need to identify the nodes. If 2 nodes are given, then you need to find 2 node voltages. If 3 nodes, 4, then accordingly you have to get this node voltage. So wherever node A connected, so according to that branch, you need to consider in terms of equations. Same for other nodes. Okay, and you have to apply the KCL accordingly. If you miss any branch that is connected with node, then you will get the wrong answer. Okay, and suppose if you have given the voltage across 5 ohm resistor, then you can write here in the equation. You can say the voltage across 5 ohm resistor. So this is your 5 ohm resistor. So according by knowing the potential, you can consider either VB minus VA or VA minus VB. Are you getting me? So voltage across 5 ohm resistor, what you can write? You are getting here a potential.
VA minus
Yes,
VB.
VA equal to 5 and VB equal to 2. So what I can write? V5 equal to VA minus VB. If you got here VB higher than VA, then you can write VB minus VA. Okay. So this is your 3 volt voltage across 5 ohm resistor. That is V5. Okay. I am giving one example for your practice purpose. Just apply the yes.
Sir, is this matrices method compulsory? Can't we do the elimination method?
Eliminations you can do if you are getting the correct answer, or if you are confident about the elimination, then you can go for that.
Okay.
But in that you'll get chances of wrong answer. So that's why we are following this grammar rule. But if in data if in exam ask example and ask apply the Cramer's rule, then you have to go for compulsory this. Otherwise, you can go for the elimination method. Don't worry.
Okay, sir.
Sir, what
Sir?
was the use of reference node?
Reference nodes accordingly you can say you can find the potential. Suppose I am considering this VA, then what actually what I can write, because I am taking away from the direction. So what I can write, VA minus, I can write VA minus VC by 2. So I can consider this potential difference. But your VC equal to 0, so equation becomes VA by 2 only. Are you getting me?
Yes, sir.
By
Yes,
knowing,
sir.
by considering these reference nodes, so you can assume the current directions. Means this is the higher and this is the lower, that is a ground potential. So the actual equation is VA minus VC by 2 for this. But your VC at ground potential, so we can directly write this VA by 2. Same you can write for this VB minus VC by 1. But your VC equal to 0, so you can write VB by 1. So that's why just we are considering this ground potential, ground potential or reference node. Okay. For just assuming this current direction means your node at initially at higher potential. Okay, I'm giving one example. Just solve it by nodal analysis. Okay, this is your 50 word. Okay, I'm just erasing this. This is your 15 word. This is your 20 word. This is your 0.5. This is your 1, 2. This is your 1. And this is also 1. Okay. Just apply the nodal analysis and find out node voltages. So how many nodes are? Suppose I am shifting this here. Okay. You can also draw like this here, or I am shifting this. So you'll get the idea.
3 node.
3.
2 node.
3.
3.
2.
Only
2.
two nodes are there. Only 2 nodes. This is your node A. This is your node B. And this is your reference node. This is V0, VA, VB. Now get VA and VB. Okay, are you getting me? The
Yes, sir.
negative terminal of active element, that is your reference node. In basically you can consider this negative wire of active element, that is your reference node, or where 3 or more elements are connected together, that is your reference node. So 1, 2, 3, 4. Okay. So where more elements are connected, that is your reference node. Now get the equations for VA. So VA is connected to this, to this, to this. Initially, just assume the current direction. You can consider all the direction away also. Okay. Or for this you can consider in, and for this outward. because this is the voltage source. Okay. Initially, you can also consider this this away also. You can also consider away also. So accordingly, you will get current either minus or plus. If your VA has, if you initially consider away, then your VA is less, then you will get negative answer. Tell me this VA and VB. You can directly go for the elimination, or you can go for the determinants and Cramer's rule.
Sir,
Yes.
sir, that could be this could be 15 ampere.
15 ampere. Which one?
Otherwise, sir, 15 volt.
Yes. This is
There can't be 15 volts, sir, because VA by we can write resistance, then it will become current, and we are showing current, then voltage can't be used.
we can use this 15 volt. This VA minus 15, we can write VA minus 15 for this.
Okay.
Okay. If you're having the voltage, so here we are writing VA minus VB. If you're considering this, then you can here write VA minus 15. Okay.
Okay. Yes, sir.
If you are considering this direction, and if you are considering this, then you can write 50 minus VA. Okay. If you are considering inward, then you can write 15 minus VA.
Sir, VA is 9.25 volt and VB is 11 volt.
11 volt.
Yes, sir. VA is 9.2 and VB is equal to 11.
9.2 and VB equal to
11.
11 volt.
Okay. I'm just checking the answer. I will give you some examples, okay, for the nodal analysis. So I will give combined assignment for unit 1 and 2. And whenever I create assignment, I will inform you, okay, don't worry. So answer is 9.25 VA and VB 11 volt. Everyone getting this answer? This is the correct answer that I have written
Yes,
here.
sir.
This is the
Yes, sir.
Yes, sir.
9.2 or 9.25.
Yes, sir.
Okay, so on tomorrow's lecture, I will give one example for the means we will do recap this nodal analysis. So I will give one example so that what we have done on today for mass analysis. So we'll get practice for this nodal analysis. Okay. So just I am waiting for the other response. Everyone getting this answer? Yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes.
Yes, sir.
The direction is considered, you can consider, if you are considering this inward, then you can write this 15 minus VA by 1. Or if you consider this outward, then you can write VA minus 15 by 1. Okay. Same for here. If you are considering this, then your VB has higher potential because you consider outward, then VB minus 20 by 1. If you are consider like this, then 20 minus VB by 1. Okay. So according to the assumption of direction, but after getting the V and VB, you can see the direction should be VA is 9 and this 15. So what your current direction should be?
Outwards.
Outward means it should be inward to VA.
Yes.
Like this, right or wrong? This is
Right,
like,
sir.
Yes.
Yes.
and for VB you are getting 11, so our direction should be like this. So it follow like this, higher to lower potential. Your VB has lower, and this is 20. So direction should be like this. Okay. So I hope everyone understood this nodal analysis.
Sir, share the PPT.
Yeah, already said. Already I uploaded in class material. So you can go through file. In file, one folder is there, class material. So in class material, this PDF, this PPT is given, or PDF file is given.
Okay.
Okay. So just go through the file. Folder is there. In that, this PDF file for this unit 2 is uploaded. Okay. So anyone having doubt regarding to this mesh or nodal analysis?
No, sir.
Okay, and whatever I am
No,
delivering
sir.
to you, whatever I am delivering to you, so are you getting me properly?
Yes.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Okay, anyone can say me. If you are not getting, then anyone can say me. Then I will change my method. If method is not going proper for this learning, then you can also change me. You can say me. Yes. Anything? What's going? Okay. So you can leave the session.